Oh, well, this is interesting because I'm using this on a new laptop. The work is backwards. So it doesn't say assignment. It starts with a T. Hi, Taylor's mom. Lurking back there like Snoopy. Uh-oh, is that your dad? I'm sorry. I've got really crappy video right now. Very sorry. Please don't shoot me. Just think of all the good things I've done for your kid over the last year, and don't send a nasty note to my boss, okay? I really don't need that. All right. Gosh, guys, I'm so sorry this is being such a pain right now. I did not want to actually have to switch computers and everything else under the sun. Okay, here we go. Okay. I swear to God, I'm living in computer hell right now. Okay, well, I just won't be looking at I won't be looking at my screen because it's completely mirror imaged, which is sort of a problem. But I'll just have to focus on looking at my big screen. Okay, so there are three different types of transformations that we're going to talk about. I'm so glad you guys are so patient with me. Thank you. Oh, Emilio's here. Let's get Emilio into the game. So transformations, is that coming out straight for you guys? You're seeing it correctly, right? Okay. On my laptop screen, it's completely mirror image. So it starts with S instead of starting with T, which is interesting. All right, so there's three different types of transformations we're going to talk about. We're going to talk about translations, which sometimes are called slides. There you go. Thank you, Mr. Dyslexia. We have reflections. I don't think I need to tell you what a reflection is, and if I do, I'm a little worried. Okay? And then finally, rotations. And I don't think I should have to define what a rotation means, but we will talk about what it means in terms of geometry. Now, so let's take a look at what that would look like. So I'm going to do some little tiny things, and then I'm going to flip back to my example, and then we'll get to work on that. Okay, so a translation or a slide, the idea is that I've got an object and I'm going to move it a certain direction, a certain number of spaces, right? So I could tell you I'm going to move it 2.5 units, or I could move it 2.35. Usually they're not evil like that, and usually they just say move it 3 spaces. Hi, Taylor's dad. I'm going to call Ms. Montoya and tell them that, no, Taylor wasn't on the call this morning. I don't know what you're talking about. Yeah, prove it. Prove it. Okay, so if I say that I want this device, or I want this square to be translated 4 to the right, I'm literally going to take like a point here, and I'm going to go 1, 2, 3, 4, and then I'm going to move that object. And this, so if this is A, this is going to be A prime. Now, we haven't really talked much about the A prime type of thing, but in geometry, they'll use that to indicate that that's like the copy, or that's where, that's the duplication. Does that make sense? So in the sense that A is our original object, and then A prime is going to be where it moved to. Does that make sense? Bueller? Bueller? Okay, Tail is nodding. Gavin's drooling on himself again. All right, so that's what a translation is, or a slide, okay? Does that make sense? Give me a thumbs up if you're like, okay, I think we did this last year, which you'd be right, you did. You should have done this last year. This is the easy one, right? This is like, oh, cool, we're just moving it. My dog could probably do that. Maybe. Then we have something which we call a reflection. Now, a reflection that looks like this is really easy. If I say reflect this across the y-axis, well, it's just going to look like this, right? It's just going to pop to the other side. This is going to be A, and this is going to be A prime. So that's going to show me that I started with object A, and my reflection across the y-axis is A prime. Now, if I started with an object like this, and I say reflected across the x-axis, well, then it's going to look like this, right? Now, even stranger, you'll get something like this. And let's say this is 3 away. And it will say, reflect this across the y-axis. Well, I can't put it here. So literally I have to figure out how far away is it from the axis here, and then count that over, and that's going to be where this one is going to be. But remember, since it's a reflection, it's got to flip, right? It can't just, it's not a slide anymore. So whatever the distance here is, let's say it's 4, then my object is going to look like this. So if this is C, this will be C prime. Does that make sense? Give me a thumbs up if you're digging how the reflection is working. Okay, people are doing well. They're like, dear God, get on with it so I can get off this call and do the last assignment and be done with math for the whole year. I'm sure none of you feel that way, right? Jill wants to keep doing math next week again. Do you want another assignment for Friday, Jill? Jill's so shell-shocked by that question, she doesn't know how to respond. How do I respond negatively? Oh, do I have it set so you can't unmute yourself? Haha, was that it? You couldn't unmute yourself?
Oh, yeah, there it goes.
Aha. So, Jill, you want to keep doing work for the rest of the summer, right? I just muted her again. I love the power. Okay, hold on a sec. Let me see if I can fix this mess. Okay, unmute all. Mute all. All participants to unmute themselves. Yes, there you go. Okay, now try it, Jill. See if you can unmute yourself and say, heck no, I don't want to do any more work.
I don't want to do any more work.
Okay, cool. Okay, now the last one that we're going to do is called a rotation. Now this is by far the trickiest of the 3 that we're going to cover. I could have covered dilations, but I decided that I liked you guys too much and that I wasn't going to do that to you, because dilations are basically where you make the object bigger or you make it smaller, and it's really pretty ugly. And I looked at it and I went, oh God, I don't want to do this, and I bet they don't want to do this. So I'm not going to do something that's going to hurt your brains the last week of our work, okay? How's that for a good deal? See how nice I am? And you thought I was ugly and stinky. Well, I'm ugly, but I just showered, so I'm not stinky anymore. I've been showering at least once a month. Now, a rotation is basically, if you imagine a string that's hanging onto this object and it's spinning around the axis, or the origin, I should say. Most of the time for right now, you're going to be spinning things around the origin. Lucky you, when you get to 10th grade and you do geometry, or for you, 9th grade, they'll have you rotate it around some point in space like over here. Or they'll say, rotate it around this point right here, and then you have to calculate where it goes from there, from that point, which is not impossible, but not really a lot of fun. But hey, what are you going to do, right? So if I look at this and I come down here, and let's say this is 3 and 3, and I need to rotate this 90 degrees. How far is 90 degrees going to be? How much is 90 degrees on this object? I'm asking you again to tell me, what is 90 degrees? Okay, let's do a little bit of review. This is 90 degrees, right? And this is 90 degrees, and this is 90 degrees, and this is 90 degrees, right? And altogether, they make 360. So an entire rotation around the origin would make a circle, right? And the degrees of a circle are 360 degrees. Yes, we remember this one before. Yes, you do remember this. Yes, hello. Do you have audio?
Saying that 90 degrees is 90 degrees.
It's 90 degrees. Very good. So 90 degrees from here is going to be over here, right? So if you imagine this object is going to move first to here, right? Because remember, it's on a string. So as I'm rotating it, it's going to look like that, and it's going to end up over at 3, and it's going to look like, so it almost looks like a slide, doesn't it? But it's not. It's not a slide. And obviously, if I did 180, it would look like a reflection then, wouldn't it? Because 180 would be over here somewhere, right? So it's really important that we understand that even though something looks like it's a reflection, it might be a rotation. Any questions? Unmute yourself and ask a question if you got one. What's the chat looking like? Oh, it's all just Gavin babbling to himself. Okay. No, so everyone's good with this? Give me a thumbs up if you're like, all three of these are cool. All of you guys get a little bit of extra points because you showed up in the last class because you're so freaking awesome. Okay. Now let's move on to actually doing some live problems, shall we? All right.
Mr. Easley, I don't have that worksheet.
No, you don't.
That
No,
worksheet is
because
not the one that you sent me.
let's see. So
My first problem says rotation 180 degrees about the origin.
well, did you download the new assignment, or are you still looking at the one I gave you a few days ago when you were begging for work to do?
I'm looking at the one that you sent me yesterday.
Okay, that was just yesterday? Heavens. So does everyone else have this one? Is this, do you have the same one? It's not? What on earth? Criminy. Hold on. Technical difficulty. Let's see. Did I run out of paper? Is that what happened? No. Okay, so nothing printed. Let's see. So hold on a second. Let me pull up my documents.
Because yours says dilation in it.
Dude, I totally believe you. I just got to find the document and see what I did. Okay.
Okay.
What on earth did I do? Wow. I printed out the wrong thing. Good job, Mr. Easley. You're like a genius. Well, not like a genius, not even close to a genius. It's more like, hello, Mr. Gerber, are you still there? It's like, yeah, I think so. Oh, gosh, I'm so sorry, guys. I didn't mean for this to take so long today.
It's fine. I don't have a life anyways.
Well, I knew that. Hold on, guys. I'm just making sure this is going to work right. Okay. Hang on, kiddos. Printing out new sheet. Does that look better?
Yep.
Sorry about that. Not quite sure what happened there. I'm printing out the sheet that has the answer drawn in so that you don't have to tolerate my absolutely hideous attempts at drawing. All right.
I downloaded it and printed out the first 9 pages because that's the assignment.
Right.
And then instead it gave me 2. It gave me 18 pages.
I'll see how lucky you are. It knew that you wanted more to do. It said, oh, that's that freak that keeps asking for extra work. Oh, my God. Seriously? Jeez Louise. All right. Never mind. Let's just keep going. I am so sorry. I thought I had this all set to go. I was all ready to go for you guys, and then criminy. All right. So let's look at this. If this is going to rotate 180 degrees, it's effectively going to be a reflection, but it's going to have to be flipped, isn't it? Because a reflection would look just like this, except you'd have it like over here, like that, right? Is that even dark enough to see? A reflection would look like this. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So a reflection would look like that's what a reflection would look like, right? Puppy. So that's what a reflection would look like, but this isn't a reflection, it's a rotation, which means that as I rotate this around, this is going to be the one that's going to be on top up here. Do you see that? Because if we're talking about a 180, so if we rotate it and we remember this is our string, so 180, the X is going to be here, isn't it? And it's going to have to be flipped like this, because this is going to keep rotating around, and this part's going to be on the bottom, right? So if that's on the bottom, it's going to first go, what is that, 2 to the right, and then it's going to go up and over 2, right? See that? And then this is 1, 2, 3 long, so that's going to be here, and this goes, wait a minute, 1, 2. What the heck? What did I do? Why for my shape not look like other shape?
You didn't, when you went to do the two up.
Thank you. See, I'm all flustered because of what happened earlier. Thank you for helping me there. I hate screwing up. It bothers me because when I screw up, then it messes you guys up. So I feel bad about that. You understand that, right? So if we look back at the answer page, thank God we've got one of them, right? Otherwise we'd have to rely upon this Easily dude for all the answers, and geez Louise, right? And so here's what the answer looks like, right? So you can see how, like I said, because it's a, come on. Anything that can go wrong right now is going wrong. I'm very sorry. So again, you can see how because this is a rotation and not a reflection, the object is going to be flipped along the x-axis as well as the y-axis. Does that make sense? That looks like a no. Let's take a look at this. Jill says, no, I get it. All right, good. Not my best job here today, guys. I'm really sorry. Let's look at this.
Sorry, I haven't been answering questions because I've been spacing out. I've been doing the problems. Sorry.
That's fine. It's all good. Hey, I've been like messing up this whole thing. So let's look at this. So if I have an object that's here, right? Now, if I rotate it, it's got to rotate like this, right? So it's going to end up over here. So it changes the orientation of where this thing is at, right? So let's do a couple more of these and see if I can't manage to unconfuse you and myself. That would be a neat concept now, wouldn't it? Since apparently I'm having some profound issues today. All right, so now let's look at this one. Now this one says rotate it clockwise. Clockwise is that way, right? The way the hands of the clock go. So this has to rotate 90 degrees. The best way to do these is to start out with, okay, this is 2 away from the origin, right? If I move it 90 degrees, it's going to start right there, isn't it? So I want to mark that as L prime. Does that make sense? Now, M, 1, 2, 3, 4, is 4 out and 3 down. So where is it going to be? Where do you think? If I flip this over, trying to make a triangle that looks similar to it. So if I have this triangle and I flip it, it's going to end up kind of looking like this, isn't it? 90 degrees? Because this is going to come right to here. So what's the relation of L to K at that point? Well, K is going to be 1, 2, 3 over 1, 2, 3, and 1 down. Right? Does that make sense? Let's take a look at the answer sheet to make sure I'm not doing something stupid. Because to be perfectly honest, this morning and after all this stuff, I totally believe I could do something stupid. So there's the answer. See how it's doing that? So right? And so this is going to be K prime. And then M is just one away from K, which is down here. And then this goes up here. So it's weird, but if you do it one step at a time, it's not that tough. Now, we're not stopping there. We're going to keep working on this, okay? Does that sort of make sense? I realize that I'm not at my best today with everything going goofy, but are we getting the idea of how that rotation works? Give me a thumbs up if you're like, yeah, I'm getting it. Okay, so about half of you are still kind of like, not so much. Oh, Logan says, okay. All right, let's do a couple translations, and then we'll find some more. We should have more rotations down further. Yeah, we'll do some more rotations later. Now, a translation, remember, is just a slide, right? So it's literally going to do like a line dance over to the left here is what it's saying, right? So it wants us to move at 5. So this is pretty easy, right? I started our 1, 2, 3, 4, 5. And this is R prime, right? S is going to move 5 to the left. 1, 2, 3, 4, 5. Q, 1, 2, 3, 4, 5. And then finally T, 1, 2, 3, 4. So when I do that up, it ends up looking like so. The translations are the easiest ones to do. Even the ones where they have you do it 1 up and 6 to the right and all that kind of stuff really isn't that hard. And we'll do one of those next just to let you see how it's not really that tough. You just take 1 point at a time, right? So let's take a look at number 5 actually. It says 1 unit right and 6 units up. Well, so let's start with W. 1 unit right and 6 units up. 1, 2, 3, 4, 5, 6. So there's W prime. Does that make sense? Now V over 1 up 6. 1, 2, 3, 4, 5, 6. So this is V prime. Finally, U over 1 to the right. 1, 2, 3, 4, 5, 6. And I end up with a congruent triangle that is 1 to the right and 6 up. Give me a thumbs up if that makes sense. Okay, Taylor, Kaylee, Jill, Mia, good. Emilio, good. Ariana, good. Logan, yes. Okay, good. So let's move on to the next one. We're just going to few these. I'm very sorry that I'm taking so long today. We'll do some more of this stuff on Friday if it still doesn't make sense, okay? I'm sorry that I lost so much time due to technical issues. Doesn't help that my computer crapped out like literally 5 minutes before the class started. Now, if I'm reflecting across the x-axis, it literally means that each of these points is going to be mirror reflected. So B is going to be mirror reflected. Oh, wait a minute. Sorry, across the x-axis. My bad. Read the question carefully, Mr. Easley. So it's 2 up, so I'm going to go 2 down. This is B prime. Sorry about that, guys. E is 2 up, so it's going to be 2 down, right? D is 3 up, so it's going to be 3 down. And C is 1, 2, 3, 4, 5 up, so it's going to be 1, 2, 3, 4, 5 down. Now I just have to connect my points, and there is a reflection. Yes? Thumbs up, yes? Okay. Let's see if I can. Oh, let's do another rotation since I seem to have hosed those up badly before. Shall we? I've only got like 5 minutes left because I have to go to a meeting. I'm very sorry. Let's take a look at this rotation clockwise. So again, I'm going this way, right? Now this one's not too tough to do. Let's see if there's an easy starting point. G is right on the y-axis, isn't it? So if I move it to the right, it's going to end up 1, 2, 3. It's going to end up right here, won't it? Does that make sense when I rotate that point? F is right on this axis, so when I move it 90 degrees, it's going to come and be right here. Now, H is 3 away from G, like this, right? And then where do you think I is going to go? Somebody tell me where you think I is going to go. Give me a coordinate if you can figure out a coordinate for where I is going to go.
Isn't I gonna go like one space away from H to the left?
Exactly. So it's going to be at 2, 3. So it's going to be right here. Thank you, Jasper. Good job. And there is my, boy, that looks really weird, doesn't it? But it is right. But it sure looks strange, doesn't it? Just to prove that I got it right, so you don't think I'm completely doofus. Here it is. Here it is right here, right? So everything rotated that 90 degrees. All right, so how are we feeling? You feeling okay? Give me a thumbs up if you're like, yeah, I can give this a shot. People doing all right? I'm sorry this was like some kind of horrible tragedy of errors. Sweet Jesus, that was a problem. Very sorry for that. Hold on, let's do